Today, we're going to follow the journey of water through what's called a resource recovery facility. We'll trace its path from, raw wastewater all the way to clean, compliant effluent. And we'll explore the really carefully engineered process that protects both our environment and public health. Okay, let's dive right in. Every good journey needs a map, and hey, this is ours. This process flow diagram shows every single stop we'll be making today. We're going to start on the far left with the raw influent and just work our way across, following those arrows through each stage of treatment. Think of it as our guide to understanding how everything connects.
So here are the key stops on our tour. We'll kick things off with preliminary treatment, then move through primary and secondary. After that, we'll see the final polish in the tertiary and disinfection stages. And finally, we're going to look at the people who make this whole system run, the operators. All right, let's get to our first stop. Before any of the really sophisticated treatment can even begin, the facility has to protect itself from all the large, damaging stuff that comes down the pipe. This stage is basically the bouncer at the front door of the plant.
So, looking at our map, we are right here at the very beginning. The water flows first through the screen, and then it goes into the grit basin. These two components are really the workhorses of preliminary treatment, and each one has a very specific job to do.
So here's the problem. Wastewater isn't just water, right? It's filled with trash, rags, wood, and all this heavy grit like sand and even eggshells. The solution is really a 1-2 punch. First, the bar screens act like a giant strainer to catch all the big trash. Then, the grit basins slow the water down just enough for those heavy particles like sand to settle out, while keeping the lighter organic stuff suspended so it can be treated later on.
Some facilities also use these machines, communators or grinders. Instead of just screening out the large solids, these devices act like an industrial-grade garbage disposal. They shred all that material into smaller, more manageable pieces that won't end up damaging the pumps and pipes further down the line. Okay, so now that all the big, inorganic junk is out of the way, we can get to the real heart of the treatment process. This is where we start dealing with the organic material. First, by just letting gravity do its thing, and then by unleashing the awesome power of biology.
Back to our map. You can see the flow leaves preliminary treatment and enters these big circular tanks. Those are the primary clarifiers. From there, the water moves into the activated sludge basin, which is really the key component of secondary treatment.
Primary treatment is actually beautifully simple in its concept. Water enters this huge tank, and the flow is slowed way down. With the water moving so slowly, gravity just takes over. All the suspended organic solids drift to the bottom, and they form a layer of what we call primary sludge. This one simple step can remove about 60% of the solids. Pretty amazing.
Okay, this is where it gets really cool. Secondary treatment is all about managing a massive living ecosystem. What operators do is cultivate this rich culture of helpful microorganisms. They pump air into the water to keep these little microbes happy and active. And what do these microbes do? They eat the dissolved organic waste in the water. That's their food. Once they've eaten their fill, the water flows to a final clarifier where the microbes settle out, leaving behind much cleaner water.
Now, what's really interesting here is how operators can tell if the process is working well. They look at something called flock. These are just clumps of microorganisms and solids. And this quote from an operator's training manual gives a surprisingly effective visual. A healthy system produces flock that looks like cooked ground beef. It's a really practical, real-world indicator that the whole biological process is humming along just right.
The water's looking a lot cleaner now, but the job isn't quite finished. Before this water can be safely returned to a river or a lake, it needs a final polish. These last stages are all about removing the absolute finest particles and any harmful pathogens to meet some very strict quality standards.
Back on our map, we're now at the finishing line. The water flows from that secondary clarifier, goes through the filter, and then into the disinfection contact chamber. These are the final steps before it's ready for discharge.
So, what exactly is tertiary treatment? Well, think of it as the deep clean stage. It often starts with filtration, passing the water through sand or cloth to catch any of those tiny fine particles that are left. It can also involve adding chemicals. For example, adding something like alum causes pollutants like phosphorus to clump together so they can be easily removed. Every step here is designed to meet the plant's strict environmental permit limits. This brings us to the final, and I mean critical, safety step, disinfection. See, even after all this treatment, some harmful bacteria or viruses might still remain. So a disinfectant, usually chlorine, is used to inactivate these pathogens.
This protects public health, and it also protects the aquatic life where the water is discharged.
So we've walked through the entire process, from the screens all the way to disinfection. But all these tanks and pipes and pumps, they don't run themselves. There's a critical human element that makes this entire journey possible.
That's the question you have to ask, right? Who manages the biology, responds to emergencies, ensures safety, and guarantees that the water leaving the plant is always clean and safe? Well, the answer, of course, is the wastewater operator.
An operator's role is so much more than just turning valves. It's truly a leadership position. They're responsible for emergency planning, managing and training staff, budgeting, and even public engagement. And underneath all of that is the constant responsibility to make sure the plant meets every single environmental regulation, no exceptions. A huge part of their job is safety. And to really understand safety, you have to know the difference between these two key terms. A hazard is the thing that can cause harm, like an open tank. The risk is the chance that it will cause harm, like the likelihood of somebody actually falling in. A good operator is an expert at identifying those hazards in order to control and minimize the risks.
And this is so crucial. A strong safety culture isn't just a rule book sitting on a shelf collecting dust. It's a living document, a program that's constantly being updated through active participation. It requires everyone, from the newest hire to the plant manager, to report potential issues and contribute to making the workplace safer.
And that brings our journey to a close. After seeing all the complex steps, from preliminary screening to biological treatment to final disinfection, it all comes down to this one simple, powerful truth. The physical and biological processes, that's what cleans the water. But it's the skilled, dedicated operator who ultimately protects the public and our environment.